Okay, we're going to fill in the chart. The first one is already done for us. You see A4 divided by 3 is the division expression. 12 thirds divided by 3 equals 4 thirds. The improper fraction is 4 divided by 3, or 4 thirds. Mixed number is 1 1/3. And then you show the standard algorithm in the last column. B, we do not have the division expression. We do not have the unit forms. We do not have the improper fraction, but we do have the mixed number. So we can get a lot of information from the mixed number. The mixed number is 1 2/5. When I'm looking at that as fifths, my 1 whole would give me 5/5 plus the 2/5 should be an improper fraction of 7/5. Because my improper fractions are related to division, I can do 2 more columns very quickly. That fraction bar represents division. 7 divided by 5. So we'll go back to column 1. My improper fraction is going to tell me 7 divided by 5. I can also go to my last column, the standard algorithm, and set up a standard algorithm of 7 divided by 5. Let's finish solving that. 7 divided by 5 is 1. 1 times 5 is 5. Subtract and have 2 left with a denominator of 5. 1 2/5, which matches my mixed number. My check would be 5 times 1 2/5. So I don't have enough room to show it, but it would be 1 2/5 plus 1 2/5 plus 1 2/5 plus 1 2/5 plus 1 2/5 5 times. My whole number would be 5, and my fraction would be 10/5. 10/5 is equal to 2 wholes. Add that to the 5 wholes, and I get 7, which is my original number. Checks. Go back to my model. Now, if I broke every whole up into fifths, 1 whole would have 5/5. So 7 wholes has 35/5. Divided by 5 is 7/5. It matches everything else. Letter C. What I do have is my standard algorithm. Let's solve it. 7 divided by 2 is 3. 3 times 2 is 6, with 1 left over. My check would be 2 times 3.5. 3.5 plus 3.5. Whole number, 6. Fraction, 1/2 plus 1/2 is 2 halves. 2 halves is 1 whole. Add it to the 6 wholes for 7. It checks. Now bring it back to column A, which is your division expression. The standard algorithm said 7 divided by 2, so that must be my division expression. In 1 whole, there would be 2 halves. So in 7 wholes, there should be 14 halves. Divided by 2 is 7 halves. 7 halves as an improper fraction looks like 7 over 2, which matches 7 divided by 2. Fraction bar also means division. For my mixed number, I have it in my standard algorithm, but I can also think of it as 6 over 2, which is 3 wholes, plus 1 over 2, 3.5. Lastly, we have 7 divided by 4 in row D. We also have 7/4 as my improper fraction. In 1 whole, there would be 4/4. So in 7 wholes, there's going to be 28/4. divided by 4 will give me 7 fourths. The 7 fourths matches my improper fraction. My mixed number would be, looking at the improper, I see 4 fourths, which is 1 whole, plus an extra 3 fourths. My standard algorithm, it would be 7 divided by 4 is 1. 1 times 4 is 4. Subtract it, I get 3 left out of 4, 1 and 3 fourths. My check would be 4 times 1 and 3 fourths. So that's 1 and 3 fourths plus 1 and 3 fourths plus 1 and 3 fourths plus 1 and 3 fourths. My whole number is 4. I have 3 fourths plus 3 fourths is 6 fourths, plus 3 fourths is 9 fourths, plus 3 fourths is 12 fourths. 12 fourths is 3 wholes. Add it to the 4 wholes, and I get 7. It checks. Okay, tough problem here to think about, but let's read, draw, and write. Coffee shop uses 4 liters of milk every day. If they have 15 liters of milk in the refrigerator, after how many days will they need to purchase more? Okay, lots of things I'm thinking of here, but I'm going to draw first. Now I'm going to put the 15, because it's not separated right now, I'm going to put 15 liters together. Now, I'm taking 4 liters every day. So I could subtract 4 liters, or I could also think of it as dividing it up by 4 liters a day. So the division expression might be 15 divided by 4. My improper fraction would be related to that, 15 divided by 4. My standard algorithm would be 15 divided by 4 is 3, with 3 left over, 3 and 3 fourths. Now, I understand all of that, but I'm not sure what my answer is, and my drawing needs to help me to figure that out. Okay. If I take 4 liters a day, there's day 1. Let's label this day 1. This would be day 2. I'm looking at 3 and 3 fourths. Here's day 3. Okay, that's 4 liters, 4 liters, 4 liters. The better you label, the easier it's going to be to see exactly what you need. Day 4, I only have 3 liters, but I need 4. Okay, so I see that in my work I got 3 and 3 fourths, which means 3 and 3 fourths days. The question says, after how many days will they need to purchase more? So if I need 4 the first day, I'm okay. If I need 4 the second day, I'm okay. If I need 4 the third day, I'm okay. But the 4th day, I'm not okay. I'm not going to be able to survive that 4th day in my coffee shop without purchasing. So after day 3, I'm going to have to think about purchasing more milk. Okay, last one for this video. If they only use half as much milk, half as much would be dividing using 4 liters. So I'm going to be using half of that. 4 divided by 2 is 2 liters per day. So that's going to be 15 liters divided by 2 liters per day, or 15 divided by 2. Okay. Or standard algorithm of 15 divided by 2 is 7. 1 left over, 1/2. So I'm thinking 7.5 days is what I could get by on my 15 liters of milk. To draw the picture will help me to think it through all the way. Okay, my draw is 15. Okay, take 2, which in my standard algorithm, I see that I'm going to need 7.5. Day 1, 2 liters. Day 2, 2 liters. Day 3, day 4, day 5, day 6, day 7. So I have day 1, 2 liters. Day 2, day 3, day 4, day 5, day 6, day 7. And I have 1 more liter left over. I cannot make it to day 8. I need to purchase right here because I won't make it through the day for day 8. So I need to purchase after 7